So this last section in our chapter is once again regression modeling, or modeling using regression, and this time it's exponential and logarithmic models. And Gia says we're fitting curves to data again. And Pam, yeah, I want to move forward, but we keep regressing. It'd probably be funnier if someone else read it instead of me, but anyway, I tried. This one is example 1. So first, before we do regression, we're going to be given a set of data, and we're going to figure out whether it is exponential or not. And in order to do that, instead of finding common differences like we did with linear and quadratic and cubic ones, we are going to find something called the constant ratio. And to get the constant ratio, we will be dividing instead of subtracting. So like with linear, quadratic, and cubic, we took a y value and we subtracted. We did a second y value minus a first y value. Well, with constant ratios, we're going to take a y value and divide it by the previous y value. So we're going to do -1 divided by -3. And the negatives cancel out to 1/3. So that's going from those. And then if you do this one, you'll have 1 divided by -1. That's -1. Here you're going to have 3 divided by 1, or 3. And here you're going to have 5 divided by 3, which is 5/3, which is about, or it is exactly 2 2/3, or 1/3 rather. Wait, 1 2/3. Gosh, I knew that it just wasn't sounding right. I need a bigger eraser. Okay. 1 2/3. So you look at all those common ratios and they're all different. So that means this is not exponential. Because ours are not equal, and not even close to equal. If it's real world data, then the r's aren't going to be perfectly equal, but if they're close, then you could say it's probably exponential. So for your common ratio, you're going to pick a y value and divide by the previous y value. So we'll do the same thing. We'll take our y value 1 and divide by 1/2. So in order to do that, one way to think about that is to write it, instead of vertically like this, is to write it horizontally. 1 divided by 1/2, because you're used to seeing it this way. And then you know to flip the second fraction and multiply. So it becomes 1 times 2 over 1, which is 2. So the answer for this common ratio is 2. I'll just circle it. The other way you can do that, if you want to leave it in vertical format, because you're doing 1 divided by 1/2, you can rewrite 1 as a fraction. So you could have 1 over 1 divided by 1 over 2. So you want to have a fraction over a fraction. And then you flip the second fraction, which is the bottom fraction, and you multiply it to the bottom and the top. And those cancel out, and you get 1 times 2 over 1, which is just 2. Okay, this one we're going to do 2 divided by 1, which is also 2. I'll put it in a circle. Here you're going to do 4 divided by 2, which is 2. This is looking pretty good. And then 8 divided by 4 is also 2. So because all the r's are the same, this is exponential. The common ratio, we call it r. Or they call it a constant ratio. You can also call it a common one if you want. And try this one on your own. So this one, I would say we might want to do it with a calculator, which I don't have my calculator turned on yet, so I'll have to get it. Okay. Clear. 4 divided by 2.666666. Whoops, come on thing. I'm too fast for it. So it's about 1.5. Again, I'll circle these. 6 divided by 4, that's 3/2. That's also 1.5. 9 divided by 6, that's going to reduce down also to 3/2, also 1.5. And then we better double check and just make sure. Whoop, this one is 13.5 divided by 9. is also 1.5. So we've got ourselves an exponential function here. I apologize for the blurriness. I made these last year and I didn't do it right, as you can tell, so it's fuzzy. The table gives the approximate values of diamonds of the same quality. Find an exponential model for the data, and then we're going to use the model to answer a question. So first let's put this in our calculator. Anytime we're doing exponential regressions, we're going to enter this in our calculator here. So we'll put the weight in L1. And remember, if you have to clear these out, you go up to the top and you press clear and you arrow down. But mine are already clear. 1, 2, 3, 4. And then in L2 we've got 920, 1160, 1580, 2150, and 2900. And then we go to a blank screen, second quit, clear all that off. And regression is still always where it always has been, under stat, over to calc. But now, see, in the past we did lid-rag, we did quad, cubic, quartic. If you keep going down, you should find exponential. There's only oh, there are some more. Oh, there's all kinds. I'm going down to the bottom just to see what's on there. Oops. So anyway, option 10 is exp-reg. That's your exponential regression. And it defaults to L1 and L2, so good there. And then I want to store this to y1, so that's vars, y-vars, function, y1. Now, and then enter. And I don't have my R. That's because I just turned this on and it clears it out every night when I put it away. So let's just see. I'm not going to worry about R on this lesson. They don't even ask about it, so that R squared, I mean. Great. So anyway, let's write this down. So we've got 814.96 is the A value, so y equals 814.96. And then the base is the so it's going to be times the base, 1.379. I'm going to go out to 3 decimal places. 1.379. Put that in parentheses and then raise it to the x. Our calculator doesn't have e as a base. They don't have an exponential regression with e as a base, and that's because any exponential can be written. You don't need an e in order to write an exponential regression, if that makes any sense. Anyway, you don't have to worry about that. Oh, what else was I going to say? Oh, I was going to say if you are on the 84, hopefully you are already well familiar with it, but there's that thing where it says calculate. Oh, that calculates at the bottom, sorry. It says store reg EQ, just to remind you. This is where you do the vars, y-vars, and so on to get y1. So we have accomplished the first question. Now on these problems in your homework, please write down the equation that you got. Then we can answer the question. So it says use the model to estimate the weight of a diamond that's worth $2,325. So first you have to decide which variable money is, and in this case money is the y variable, because this is x and this is y. So if we know a y value, we have to go to our calculator and go to y equals. There's the exponential equation because we put it in there. And then we're looking to know, basically what we're doing here is we're trying to find out when 32325 is equal to. See, I'm plugging in the 2,325 in for y. And most of you guys should already know all this. I mean, you were familiar. We've been doing this all semester, all year actually. Oh, where did you go? Uh-oh, that's not good. Did you see that? It kind of did the... Oh, there it is. So in y2, you're going to do 2325. And I think I better set my window, because if I just press graph, I'm not going to see anything. So we can base our window on our table. Our x's go from 0.5 to 4. So I like to see a little bit around it. So I'm going to go negative, whoops, I meant to say -1 up to, I'm going to say 6. Give it some room on either side. And then the value, let's say from 0 up to, well, we know it has to go up to, we want 2,325. So I'm going to go, well, and I've got 2,900. I'm going to go up to 3,000. Oh, and we have to turn, well, we don't really need our stat plots. You can turn your stat plots on, though, to see how well the curve fit the data. I'll do that real quick because it doesn't take long. Second y equals, enter. Enter for on. Everything is defaulted the way we want it. You can see how nicely the curve fits the points. Great, so now we're going to find where they intersect. The easiest way to do that, in my opinion, is second trace, intersect, enter, enter. Oh, enter, okay. 3.26. So at about 3.26 carats, I don't know the abbreviation for carats, that weight will result in a diamond that is worth about $2,300. So this is the answer. So this one is for you to try on your own, and then you can watch the video to see how it's done. Okay, so I'm going to try to go a little faster on this one, so I don't take up too much of your time. So I'm going back to edit. Come on. I'm going to clear these out. Over, up, clear, down. 0, enter 1, enter 2, enter 3, enter, whoop, backspace. 4, enter, 5, enter. Oops, look at that, I made a mistake. What is going on with this thing? 2, I'm doing a really bad. What? Come on. 2, enter. Enter? You know what? No? I was wondering if it wasn't calibrated. Let's try this again. I'm going to clear it out and start over. Okay. 0, enter. Why is it not doing enter? It's doing plus. It is so weird. Okay, I'm going to bring it up here. Maybe it'll work better up here. Stat. Because you probably have your data entered by the time I get mine going. 0, enter. Good. 1. I have to treat it very carefully. 2. I guess it can't be too far down on the border. It doesn't work correctly. Good. We're in business. 200. 248. 312. 390. 489. And 610. Okay, I think I'll go ahead and set my window while I'm at it. I just feel like doing that right now. -1 to 6 will work well. We don't need to go up to 3,000. We could go up to, well, say 500, 600, 700. How about? Okay, if you feel like it, you can graph it and look at your points. Oh, I've got that old equation in there. You can see it up there. I'm going to go back and clear those out. Now I'm going to go back to a blank screen. And this is where we'll do our stat calc. Lin reg. Now I happen to remember it was option 10. So, oops, maybe that's not going to work out so well. Never mind. We'll just arrow down. Okay. And then vars, y vars, function y1, enter. You can go to graph and we see the curve fits the points. Great. So then I'm going to go back to my equation so I can write it down because it asks, I want you guys to write down the model. So it's 199.29. That's the A value. And by the way, you remember what that stands for? That's the initial Y value. And then the base is 1.25 to the X. So that's the first task, is to get your equation. And then it says, when will the bacteria reach, 2,000. Okay. So that, again, the bacteria is going to be my Y value this time. Again, because it's the Y's. So I'm plugging in 2,000 here. So I want to know where the Y's are equal to each other. So I need to go back to Y equals. And in Y2, I need to put in 2,000. Man, it just doesn't want to work very well. Okay. And I know if I press graph, I'm not going to see it because I need to fix my window. because my y's were only 700, so I need to get above 2,000. I'm going to do 2,500 because I like plenty of room. Oh, and we also need to make our x's bigger. I'll do 25 and see what we get. Oh yeah, plenty. Then we can do the same old thing. Second calc, intersect, enter, enter, enter. At about 10.3 minutes. So at about 10.3 minutes, or about 10 minutes, we should have around 2,000 bacteria. Doesn't take them very long, does it? To get big, high amounts. So now we have this data, and we notice it wants a natural log model. I suppose I should read the whole thing. A table gives the Richter scale equivalent for an explosion involving a quantity of TNT. Find a natural log model for the data. Use the model to estimate the number of tons of TNT that would be the equivalent of an earthquake, measuring 6.5 on the Richter scale. Wow. That would be something else. So, sadly, these are really hard to read. So this is 1 ton. This is, I think that says 30. I think those are each 10. This is 1,000. And there's 3 10,000s, so 30,000. Okay, we'll put this data in our calculators. Same old way. Let's clear out a bunch of this other stuff. So stat, edit, so enter. We'll clear, down, over, up, clear, down. Okay, so I've got 1, 30, 1,000, and 30,000. And then my Richter numbers are 2, 3, 4, and 5. And let's do a window and graph these. So my x's are going from 1 to 30,000. I think I'll do like a -10, although it's probably not okay. So max, we need to go bigger than 30,000. I'll do 40,000. And our y's are the small numbers. So maybe from 0 to, let's go up to 6, give plenty of room. Let's graph them and make sure we see them there. Oh, I only see 2. That's weird. I think the reason might be, oh, see how because 30,000 is so big compared to 1 and 30, that 1 and 30 are both really close to the x or the y-axis here. So there's actually 1, 2, 3, 4 points. So what I'm going to do, just so I can see them a little better, I'm going to make this like -1,000. Whoops, gosh. Let's see if I can see them better. Not too much better. Anyway, back to a blank screen. Clear that off. So this time we're doing logarithmic regression. So it's still stat calc. And then this time we're going to arrow down until we get ln reg. So that is natural log. So our calculator has natural log. And we default to L1 and L2. And then let's do the vars, y-vars sequence. Enter. Okay, so here's our equation. Y equals A, so A is about 2. Y equals 2 plus. The B is 0.29, and then natural log of x. X is our variable, so it needs to stay there as x. Here is the logarithmic equation. Also, because I put it in y1, I can graph it and see that it does fit these points. Now we get to answer the question. Use the model to estimate the number of tons. So tons, okay, and measuring 6.5. So 6.5 on the Richter scale is over here. That's in the y's again. So we're going to do the same thing. Go back to y equals, and in the y's, that's not 2,000, that is 6.5. And you can guess ahead of time how much you think you're going to need. So guess and see what you get. Let's see what we get. Graph. Oh, it's not even going to be on there, right? 6.5, so I have to change my window. because I had y max at 6, so I'm going to make it 7. They're going to cross way out there, so I need to make my x's a lot bigger. I'm going to just go big. How about 100,000? Man. 0, 0, 0, 0, 0. Holy moly, look at that. Wow. So x max has to be really big. Let's add some more zeros. Let's do a bunch of zeros. That's probably too big. Oh, yeah, that's pretty big, but that's okay. You can see them. Second trace. Oh, yeah, intersection 5. I'm just going to do enter, 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 and see what we get. So 5 million. I'll just say, so going back, that's about 5.3 million tons are needed. Did you guess that high? 5.3 million tons are needed of TNT. And there's one last one. So here's an on your own if you want to try this one on your own. Stat, enter. Let's clear these off. Okay, our x's are 1, 2, 6, 7. And our y's 0.5, 2.5. Okay, so our data has been entered. And let's change the window so we can look at our data. So the x's are going from 1 to 7, so I'm going to go from 0 to 10. Well, 11, I guess. And then these are going about 0 to, I'll do 0 to 10 again. Y min 0, Y max 10. Let's graph them and see. Oh, I've got those old equations in there, so I need to clear those out. And that does look very logarithmic. Definitely not exponential. So let's see, second quit, clear, stat calc. We have to go down to ln reg, natural log. And let's do vars, y vars, enter, enter, enter. And we'll write down our equation. 0.587 plus 2.638 natural log of x. So please write down your equations when you're doing these. And then I'm going to press graph to make sure it goes through there, which it does. And then we can answer the question. When will the speed reach 8 meters per second? So again, they have given us a y value. So we'll put that y in y2. 8. And then we get to graph it. Oh, got to change our window. We need larger x's. Let's do 25. Great. Second trace, intersection, enter, enter, enter. They cross at 16.6 minutes. Now one thing, none of these questions asked you, none of them gave you an x and asked you to find a y, but let's just review in case they did. Say they said, find the speed at 10 seconds. Then, just to review that, let's go to y equals and clear this off because we don't need that anymore because we're answering a different question. What you could do is you could go to your table or you could do value. So you could press graph and then you could do value, which is second trace, and value is the first one. And you could hit enter in your x, which in this case is, man, tell ya. And you would get 6.66. And you could look and see, that looks reasonable, I would say. And of course the other way is to use the table. You could do second table set and you could start it at 10. Of course the 0 is not working well for me today. And then second table, and you could see the answer there in the table. So that's a couple of ways, if they give you the x, how to find the y. And that concludes the lesson.